Good morning, everyone. We are Group G32, and today we are presenting our BTech project entitled Intracode Security Analytics under the guidance of Umar Sharif Terdalkar sir. This project focuses on improving software security by analyzing the third-party dependencies, detecting the vulnerabilities, and ensuring the license compliance of your software project. So, about the introduction, in modern software development, developers heavily depend on the third-party libraries and the packages to speed up the development. However, these dependencies may introduce security vulnerabilities and legal risk related to software licenses. So, our project, that the Integrates Security Analytics, helps the developers identify the vulnerable dependencies, check the license compliance, and maintain a secure software supply chain. It also integrates directly with the Visual Studio Code, making the process seamlessly for the developers. The problem statement is that today's software projects rely on multiple external libraries and the frameworks. Managing these dependencies manually is difficult and risky. Existing tools are often fragmented, meaning the developers need multiple platforms for vulnerability scanning and compliance checking. Most tools are also lacking the continuous monitoring. To solve this problem, we are developing a unified platform that analyzes the dependencies, detects vulnerabilities, and continuously monitors the project in real time. So we have also done some literature surveys. During our literature survey, we studied several research papers related to software dependency securities. Some studies also focused on dependency vulnerability analysis, while others explored the developers' challenges in dependency management. However, we identified that the common limitations such as lack of ID integration, absence of real-time monitoring, and poor workflow support. Our solution improves upon these limitations by providing a real-time monitoring, easy to understand alerts, and the project-based scanning directly through Visual Code integration. Our objective is to firstly to generate a complete software bill of material, also known as SBOM for uploaded projects. Then secondly, we detect the dependencies vulnerability using the trusted database such as OSV. Thirdly, to provide a continuous monitoring and updates reports through an interactive dashboard. And the final is that to integrate a seamless Visual Studios code for real-time developer supports. So about our architecture, as you can see that there are user dashboard, then vulnerability assessment and license compliance modules. Then the request is made to the API calls. API calls are made to the backend Flask that is basically from Python. We have used databases of OSV database, OWASP license, and SQLite to do the vulnerability assessment and license compliance task. Then we have used HTML TypeScript for our extension that we have used in VS Code. Then a personal token is used to verify the user and connect a session between the backend and the VS Code. The modules that we have made as firstly the user dashboard that provides a report and navigation, the vulnerability assessment module that scans dependencies and checks against databases like OSV and OWASP. The license compliance module identifies the software licenses and flags risk ones. The sign and sign up module basically for authentication. And finally, the VS Code extension that enables the developers to scan the project directly into their coding environment. The requirements that basically need is we need a minimum Intel i3 with a Gen AMD equivalent laptop or PC. Then it should have at least a storage of 20 GB SSD. It is compatible to any software that we use or OS that we use. It is Windows, Ubuntu, Mac OS, or Arch. The languages that we basically use in this project as Python, TypeScript, JavaScript, and HTML. We have used Fast as a backend framework. Databases are simple. For vulnerability assessment, we have used OSV, and for local database, we have SQLite. So this is the project plan that was carried out by us throughout the months under the guidance of Sir, and the references from which we uh, understood what our project needs and what we can upgrade in that. So now that we have explained the concept and architecture of our project, let's move to the live demonstration of our intracode security analytics. So this is the landing page of our framework, which is this shows you how we can use the intracode with the steps Then we have also our extension that we can download through here. This shows the steps how we can use our extension of VS Code. We can download through here. Now let's see the login. So we have logged in successfully. So basically on the dashboard, you can see that there is a personal access token which we use to connect the VS Code to our backend. We can copy it from here. We will see that later. Then we have three models, that is manage, where we can upload the vulnerability assessment. We can see here, and this is license compliance. So let's see how we can upload. So this page that is uploaded is CI. I have already uploaded an project here. As you can see, it shows that the status are already connected with my VS Code, as I have already done it here. Then in this project that I have uploaded on our site or our Intracode security analytics, it has a total of 1,231 components. That is basically the libraries or the dependencies that are being used in our project. And we see that there are 12 unique licenses, and we have found critical vulnerabilities around 25. This page basically gives you the overview of what are the dependencies and licenses used in project, what are the vulnerabilities. This page is basically gives the overview. As you can see, there are chart showing that most of the licenses are based on the MIT, then vulnerability chart. Here we can upload the project. As you can see, we can upload the entire zip file or the specifically dependency file, for example .yaml or JSON files. Then we can also upload Docker image or existing the JSON file format here. This also gives you the overview that what are the dependencies or the libraries that we have used in this project. As you can see, Adobe CSS tools with its version and the license that this tool is included with. It has two vulnerabilities. Now, if you have to see in depth what actually this means, that this is trying to tell us, we have to go to vulnerability analysis. This is our another module. So firstly, when we come to the vulnerability assessment, you can see that there is a graph showing that at the center JavaScript, mostly the backend of this project is from JavaScript. And the nodes that you see here in the blue color, they are all the files that are present in that folder. As you can see, product.jsx or the feature cart JSX. These are all the files that are present in that project. Now, if I click on product.jss, it tells that there is a severity of high. Why? We can see this in this green box. It tells that there is a import link from React router DOM. Then why does this import in the file as an vulnerability? So if you come here at the right down side, it will tell you the common vulnerability exposure CVE and with the ID also. If we copy this, yeah, come here down, this gives you the basic idea of the number of vulnerabilities or the category. We come here and just paste it. We see the summary in short that why that package is vulnerable, or if we want to know it about in depth, we can just go to this site that we have used for our project. This is the NVD site, which is the government site that gives you the overall real-time vulnerability detection database. So we can see why that package was affected in here. Description is given, also the versions that were affected, and all the details here. Back to this. So this is the graph that helps developers to understand clearly and easily that what are the what are the problems or the bugs or the vulnerabilities, and where are they exactly present in which file, and what other files are they affecting. As you can see this, if I click on the categories or JSS, it has outbound 3, means there are 3 imports in this files. It shows this. This is the in-depth vulnerability inside of the project. It also shows all the, this has the critical vulnerability of 4 point here, CV2025 from data. This package has been exploited or compromised with a version of 3.0.1. Now moving to the last model is the license compliance. So license compliance, why is it important that license compliance is every package or the dependency that we have seen on the npm or the other sources, they have to be licensed under certain organization. It should have, it have some rules. For example, there are multiple organizations like MIT, BSD, or the Apache, like that. So certain organizations have their rules that are mostly static for all the dependencies that are under them. So we have categorized them into permissive, weak copyleft, and the strong copyleft, and the priority. Permissive is very simple that there are very few restrictions. You can use the source code. It is open source. You can update it. You can use it as you want. Vcopylate says that if you change certain files, you must share those changes. You can still use it in private software. Like that, we have categorized into four types. And as you can see, this project has mostly 12 unique licenses. Low risk is 1219. Means why low risk? Because all the licenses that are mostly used in this, all the packages that are mostly used in this project are under the MIT license, having the most low risk, because MIT allows you to change the package code or the source code and as you want. So as you can see, this React Toastify or the other, we can say Babel, Compact Data, they all belong to MIT licenses. Apache also doesn't have much restrictions on their dependencies or the packages which are under there. So we have shown that the usage is transitive and the risk is low. As you can see the packages, we can see that its licenses as MIT, it's permissive, it is easy to use, no restrictions are there, risk is low also, and the package version is also mentioned here. So it is important that the developer should know what dependency or the packages is he using, and what are the rules behind that uh, package or the dependency that he is using. This is the work of license compliance and governance. And lastly, that there is our VS Code extension that helps the user or the developers to easily keep the track of real-time monitoring of the project, instead of always uploading the zip folders, for which takes a hectic time to extract or to do the mm, task. You can download it for me. As you can see, it is downloading. So now coming to the last part, that is our VS Code extension. So you can know that you can download it from here. Now let's follow these steps and see how our VS Code extension works. So coming to the VS Code, so this is our extension folder. Just we have to open our folder and click the F5 button on your keyboard. As I click on F5, you can see that a new tab has opened with and I have an already existing my project that is I'm working on. So as you can see on the corner at the cursor, that it is showing that connect to SBOM. As I click on it, I'm redirected to my page. So let me log in. So I have logged in and just copy this token from here, and you can see there is a from token. You try to submit it. Okay, now it is showing that it is done. Just close it. Now basically the five steps that were told, it is basically done. It was as simple as that. We have to just open the new for our folder of the extension, then press F5, a new for VS Code window will open. Enter the copy the VS Code token and enter it here. The connection is done. As you can see, it's connected to SBOM tracker. And in the mean, you can also see that it is showing that user Amar VS Code extension connection status is updated to connected.